Okay, we are live now. Let's wait for others to join a couple of minutes. Okay, in meantime, I will start. So, good evening, everyone. Welcome to our ML Math Club event day 9th. Let me introduce myself. I am Sarita Shukla from TFUG Ghaziabad team, and I will be your host today for the session. So, today we have a exciting session planned for you folks that will be bridging the gap between the theoretical math and practical data analytics applications by Vikramjit. Let me give you a brief overview also for our session. So we will be starting the presentation and then we will take Q&A sessions. The questions you can just ping it in our live chat um, that will be for your queries and all. So you can just drop your questions and let me Okay, let me start. Okay, let me introduce our speaker, Vikramjit Singh. So he is a esteemed product data scientist in Cadient company, and he's also been holding a ample year of experience in the same field, that is product analyst and data analyst. And he's also been part of a lot of hackathons as a judge, and also being part of a tech speaker. So today he's sharing all the practical data analytics and how it's going to work. So yeah, I am welcoming you, Vikram, to share your knowledge today. It's over to you. The stage is all yours.
Thank you, Sarita. Thank you very much for the introduction. Let me present my screen now. Just a second. Is it visible, Sarita?
Yes, yes, it's visible.
Perfect. So, hi everyone. Vikram Jeet here, and I have overall 3 years of experience, and I have worked as a product data science in KDN, and in my past, I have also worked as a product risk analyst at Swiggy, where I used to look into their product called Instamart, which is a grocery delivery app that is competitive with Blinkit. So I used to take care of the risks over there and basically help them save their money from the frauds. And this was my role over there. And I have overall, as I mentioned, I have overall 3 years of experience. And during this time, I have worked in various fields like RPA, data science, data engineering, and data analytics as well. And my stronger point is data analytics. Coming to the next slide now, coming to a topic which is bridging the gap between theoretical maths and practical data analytics applications. Okay, so first things first, you must be thinking that why have I chosen this topic? Like, why should didn't I directly approach with the maths and all? Like, we are using this maths in data analytics and all. So there's a thing like since we all are tech enthusiasts, since we have joined here in the TFUG group. So as we are tech enthusiasts, so we are having some bit of knowledge of maths as well, and we are curious to know like we have some curiosity that how is maths being used in other fields in the tech. Now be it now if someone has joined in the ML maths clubs here, so they are interested in knowing the maths behind everything. So I, being an analytics professional, I will here show everything what all is being used in the basic maths which is being used in the analytics field. So I will cover that part. So we have learned maths since the very beginning as well in our schools. From the third grade, we started learning the graphs and everything. And till our 10th standards, we had started learning the mean, median, mode, and other probabilities. And if we chose in maths in 11th and 12th or in a graduation, we came to know about other concepts of maths as well. So I will be covering them on somewhat, like how are they being used in the industry, and I will basically bridge the gap, like what is the difference in the theory and the practical part, like how are we bridging it. Okay, coming to the next part now, importance of maths. So this is, you can say, very uh, you can say this is a very common thing that maths is being used every day, like it is very important for us. But still, it when it comes to us, like how is maths important to us? So we don't know exactly. So maths is being used in every aspect of our life, be it the doctors we visit every time, and they check our pulse rate and all via their machines. They are using physics, and in if we talk about the share market, in share market as well, we are using maths every day to make up the predictions as well many a time, that how will this share perform in the future, further future. If I talk about other scenarios, like making predictions of whether a candidate, how much a candidate is fit for a job or not. These days, these tech companies are using a lot of complex mathematical algorithms in their internal systems to shortlist and you can say segregate CVs based upon their requirement, and then they hire. So maths is being used everywhere these days. Now, as we have just entered the Olympic space now, the Paris Olympics is going on. So many of the teams are having their own coaches, and there they are having sports data analysts, and there they are having other people as well in the team which are maintaining the data for the players, be it their health data, or their pulse rates and all, or their performances. Cricket, we have seen that everywhere in cricket as well, maths is being used these days. Whenever we are watching an IPL or something, uh, in the bottom window, it always shows that maths, there are these much percent chances of winning, or this much is the score predicted for this team, etc. So everywhere we are using maths. Now, how are we using maths in analytics? And before that, what is analytics? So this is the big question of the day. I'll be answering that now. Let's go towards the theoretical language first. Analytics is the systematic computational analysis of data. It's a powerful tool that helps businesses make informed decisions by transforming data into meaningful insights. This is, you can say, the uh, normal bookish language, but through analytics we can uncover patterns, predict trends, and understand the customer behavior, which are critical for strategy planning and operations. Now let's delve into the role of maths in analytics. Mathematics is the backbone of analytics. Without maths, I cannot imagine my profession itself. Just a second. Yeah, sorry. Yeah. So I was saying that mathematics is the backbone of analytics. Without maths, I will be unemployed. There will be no jobs for the analytics space or data science space. So these data fields have gotten developed from the statistician roles and other roles similar to that industry related to maths. So maths is being used there, and providing mathematics, as I mentioned, is the backbone of analytics, providing the tools and frameworks needed to process and interpret data. So we do this like we basically do computational analysis. We do use uh, computer programs, and build up logics as per our needs, and build up models as per our requirement to analyze the data and understand what we need from that. So here's how maths plays a crucial role in different stages of analytics. Now, if I talk about it, like in data cleaning and collection, as as we know that in analytics there are various steps involved, like collection of data, cleaning of data. Before that, we shortlist which variables do we need, and how many variables are we needing, or what variables fit our requirement, and based upon the correlations and all. So maths is coming up there as well. Like if I talk about the data collection and cleaning part, we are using arithmetic and algebra to pre-process the data. Like for example, whenever we are having missing values in the data, uh, then we tackle them by using mostly we tackle them using measures of central tendency. Like if there are lesser values in the data which are missing, then we use measures of central tendency like mean, median, mode for that. So this way we are using maths and analytics in the sub process of analytics. This is just one part which I covered. Now if I talk about perform descript sorry uh, we use maths in other parts of data analytics domain as well. As I mentioned, cleaning and pre-processing. Then, if we want to understand the data, see the trends in the data, then we use it. And in that, there comes different types of analytics. Like we have just a second. Let me move forward in this. Yeah. So the common types of analytics which we are having are first is descriptive analytics. Descriptive analytics focuses on summarizing historical data to understand what has happened in the data in the past or in the recent time, and this includes making up reports and dashboards and data visualization. So this is the most basic analyst role which is there in the market. uh, just a second. Yeah. So this is the most basic analytics role which is present in the market. Like you must have seen there are roles for entry level analysts, and there they want analysts to perform the basic dashboarding, reporting parts, and give the insights based upon the data which they are based upon the moment whichever they find in the data. So yeah, this way descriptive analytics works. And if I talk about the biggest example of descriptive analytics, we are having share market. The share market tells the users, or you can say shareholders, or the people who are interested in it, that how is a particular share performing in the market. Now the numbers change every second. It is the real time analysis of data, and based upon that it is showing up the values in the graphs to the other people. So this is descriptive analytics. Like this is happening in the market. And coming to the next part of analytics, which is diagnostic analytics. This examines data to understand why something has happened. Basically, doing an RCA on the data. This is what happens in the diagnostic analytics. We do RCAs a lot in the analytics space. If I talk about my example, I have worked in Swiggy and I was the part of their risk analytics team. So I had to deep dive into the data and understand that why is something happening. And let's take an example of a scenario. Like for example, during the Diwali times, as we know, the demand for uh, the orders increases a lot. You must have seen that on LinkedIn or on other platforms, the CEOs of these quick commerce companies are posting regularly, like we have delivered this many packages of X product or X thing in this city and all. So it is like it shows that their demand is there. So in diagnostic analytics, basically we analyze, uh, we do the RCS, that if something has happened, then why it has happened and all. So during my time at Swiggy, it was Diwali time, and we saw a spike in the frauds in the city of Jaipur. So I, being the analyst there, I had to do the diagnostic analytics analysis of the data and understand why is it happening and all. So for that, I deep dive into the data. I looked into the various what are the various KPIs which we are having in our internal system, and I found correlation between the things, like if the fraud is happening, then it is happening on which particular type of product. Then if it is happening on this product, then why is it happening? And if it's happening, then it's happening in which specific region. So deep diving into the data, basically drilling down into the data and identify the anomalies and correlations, so that we can build up the answer for this, that why something is happening. So this is what we do in the diagnostic analytics. As I mentioned in my Jaipur case study, like I deep dive into the data to understand that why is the fraud in Jaipur city increasing. So there, I it is something confidential which I cannot say that why was the fraud increasing and all. But after drilling down and looking into the various data points, I found out that this is the reason that why is this happening. Okay, coming to the just a second. Coming to my next slide, next type of analytics, which is predictive analytics. Now this is something which correlates to the data science field. In this, basically this uses the statistical models and machine learning techniques to forecast the outcomes based on historical data. This helps anticipating in and telling in what has happened in the past, and based upon that we predict that what will happen in the further future. The biggest example for this is the sorry the just a second, let me think. Yeah. So the biggest example we can take for predictive analytics is the price of an item, which we predict that what will be the price of that item in the further future. So let's say the Maggie packet of X grams was coming in 2010 for 2010 to 2015 for 10 rupees. But then with time, its value, its amount, the quantity of Maggie started getting reduced, but the price was same. Now, if we predict that in 2030, what will be the price, then this kind of an prediction, or this kind of problem solving, or you can say this kind of analysis, is called predictive analytics, that we are predicting the value of something. Inflation, for example, as we know that recently we got our budget and everyone is just booming around it, that everything is got so expensive and all. So so we predict the inflation as well, based upon the predictive analytics, and we decide whether how much the value of a single 1,000 rupees, or you can say 1 lakh rupees, will be in the further future. The parity rates and everything we compare it. So this is what predictive analytics is. Next up, I come to the prescriptive analytics. This is the analytics which is recommends the actions we can take to offset. Just a second, let me read it out. I have this statement. It recommends actions we can take to affect desired outcomes. It combines predictive analytics with decision making algos to provide advice on possible courses of action. So basically, we are predicting, based upon our predictions, we are telling that what action do we need to take. So, for example, the biggest example for this is the inventory management system. We must have seen in these grocery stores, which are like, for example, More or Reliance Smart, etc. Uh, they are having, they always have their stocks full. Like it rarely happens that most of their items are not available in the shelves and all. So how do they do that? They look at the demand, that what has been the demand of a specific entity in the system in a specific area and in their specific store, and then based upon that demand they predict that how many days will the stock, or you can say the supply end, or their quantity end of a specific entity, and then based upon that they predict that in how many days we have to do this, and we have to provide a new lot so that the customers are able to find the relevant product in the relevant time. So this is what happens in the prescriptive analytics. Like we have predicted, and then based upon that we have supplying the resources as much as as perfectly as required, not too much, not too less. So this is what happens in the prescriptive analytics. So these are the most common types of analytics practices which are there in the market. And the first two, this descriptive analytics and diagnostic analytics, these two are the ones which are mostly used in the data analyst, product analyst, and business analyst roles. The other two, predictive analytics and prescriptive analytics, these come under the data science space because we are building up models in this. So these two comes under that, and for that, we use these two. Uh, we will not be discussing these two types of analytics because I am proficient with the descriptive and diagnostic ones. So I'll focus completely on these. Coming to the next part, maths used under each type of analytics. First, let's talk about descriptive analytics. In descriptive analytics, we are using statistics for measure. Under statistics, we are using measures of central tendency, which are mean, median, modes, and measures of dispersion, which are variance and standard deviation, percentiles, histograms, etc. Second thing which we use is data visualization. Like we are building up graphs from the data, and based upon those graphs, we make up the decisions like how has something performed. As the name itself suggests, it is descriptive analytics, that we are describing, we are providing the description for something like what has happened or what is happening in the data. So, in the descriptive analytics space, these are the few types of mathematical techniques which we use. I will deep dive into these in the next slides. Next, if I talk about diagnostic analytics, we use inferential statistics like correlation analysis and p-values. Now, let's take the example of something like we are predicting that how has the price of something changed based upon the other thing. Uh, so let's say the price of a biscuit packet has increased from 5 rupees to 6 rupees. So why has it happened? So if we do the diagnostic analytics for it, like why has the price changed, we will do one of the things which we will do under that is the correlation analysis. We will look into few factors which like is the transportation cost has increased or not. Secondly, are the prices of petrol increased or diesel increased. Third, is the price of the raw material which we use that has increased. So we will these are some things which we will analyze in an entity. So we do the correlation analysis in such cases, and p-value and all as well. I will come to that part too. Multivariate analysis we do in the diagnostic analytics. Under that we do the cluster analysis, like sorry building up small clusters of the data of the data entities, and then understand that how are they performing. So this is what we do in cluster analysis. Next, regression analysis. Yes, this is very important, and you can say this is the starting point of ML. So regression analysis to identify the relationship between variables. So we do correlation analysis as well for understanding the relationship between the variables, but the linear regression or the regression analysis tells us that how has the data been performing in the past few times, like not just the single value but all the values in the of two variables, how are they performing and how has been their relation been. So there we use regression analysis. Next up we come to the predictive analytics part. In predictive analytics, we use probability theory, like understanding modeling, uncertainty, random variables, distributions, etc. Next up, we do a lot of machine learning algorithms like linear regression, non-linear regressions, and classifications, as it is mentioned, decision trees, SVMs, clustering techniques to time series analysis for the data whichever we are having. And then coming to the prescriptive analytics part, the deeper one, linear programming, integer programming, non-linear organization, and all they do. Operation research like queuing theory, network theory, simulation of models for complex making scenarios, etc., etc. So, and next game theories, like there are different techniques. So, strategies and decision making in competitive environments. So, these are the types of maths which we specifically use under each type of analytics, like these many techniques. Now I will deeper dive into these two types, descriptive analytics and diagnostic analytics. I will deep dive into these two. Coming to it now, concepts needed for a data analyst, like for a basic data analyst job, or you can say a business analyst or a product analyst job, we mostly require descriptive and diagnostic analytics. Okay. So I will be now covering these two. If I talk about an example first, during my previous roles, I have worked as a data science analyst as well and business analyst as well in a few of the my previous companies, and in them, my role was to, if I put it in a nutshell, my role was to make up dashboards, maintain dashboards, create them, and provide the data as per the need of the senior hierarchy, which is like the VPs or CEO of the company. I have directly worked with them. So the descriptive analytics is what we firstly perform there. Then, like if we have informed the VPs or the senior hierarchy of the company, like this is happening and this has the movement of the share or whatever the movement of the product, or this has been the fraud. So what are the steps we can take, or before that we discuss it like why it has happened. So under that the diagnostic analytics part comes into the place. So these two are the major parts which I have worked upon, and now I will discuss the maths behind these two. Coming to the descriptive, sorry, how mathematics is applied in the descriptive analytics. So I will give example for each of these four concepts which I have written, because these are the we can say the beginner friendly tools which are used in the descriptive analytics. So measures of central tendency are used a lot in the descriptive analytics, like mean, median, and mode. And now if we talk about like why are we using it, now let's assume that I am a data analyst now, working for a fin uh, working for a company which sells clothes. Okay. Now I want to understand what has been the average sale of the whole quarter. So for that, I will use mean, the most basic one, the mean I will use. Then I may use it to understand like if I have gaps in the data, like let's say we have some values and we have 10,000 records, and out of those 100 value, or you can say 50 values are missing. So for filling up those values to get some idea that this has our data has performed, we can use mean values of the other values which are available, calculating the mean of those values. For the overview part, for descriptive part, or descriptive analytics. Okay, coming to the median now. How are we using median? So let me think of a scenario. Mm, okay, so many a times, uh, like we can use median in investing, like to decide whether to invest based upon the returns or not. For that we can use the median of the returns. For example, if the median of the return is 20%, half of the returns were lesser than 20%. So when we calculate the uh, median, we firstly put up all the data in the ascending order, and then we calculate the median for the data. Now if I took the example of the returns of a share, or we can say the returns uh, of a SIP or whatever, the mutual fund, sorry. So if the return is 20%, so that tells us that 20% is the median value. Median is 20%, and that tells us that 50% of the data, or you can say 50% of the profit was less than 20%, and rest was more than 20%. So this way we are using measure this median in the descriptive analytics space. Now modal values, I am working for a uh, grocery store, for example. I am an analyst for Reliance Smart. Sorry. Now I'm working as a analyst for Reliance Smart, and I have to see that which SKU is being sold the most. So for that I will use mode, obviously. So this is how descriptive analytics is being used. Under that, measures of central tendency. Now formulas for these are obviously available in the web, so I won't be sharing the formulas for anything, but I will be giving up, as I mentioned in my topic itself, that I'm bridging the gap between theory and practical implementation. So I will be giving the examples for each and everything, so that we are having in basic understanding that how are we using maths in a day-to-day analytics or day-to-day analysis of things. Okay, coming to the measures of dispersion part now, standard deviation. So let me think of a scenario for this. Mm, mhm. So let's take the example, like choosing a TV show to watch. Okay, no, 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 we can't take that measure of variance. Yeah, so scores of a test we can assume, like let's say we are having the scores of a kid is having a score of his friends, like I am having my score which is 85, friend is having 90, friend 3 is having 95, 4 is having 70, etc. So to understand that how much is the on an average difference, or how much the score of each friend score differing, or a friend circle differing in total from each other, the difference, or how much there is a gap between on the average gap between the scores of all our friends, how much is it? For that we are using measures of these dispersion. So for that we use standard deviation, and variance are the majorly used part. Coming to the next one, percentiles we use, like to understand how is the data perform. Guys, I can see some of the questions popping up in the screen. I will be taking them in the end, as the host just told us. So I will be working that way only. And so Madhur, I will take your question. Millie as well. I will take your question in that point of time only. Okay. Coming to the next part, percentiles. How are we using percentiles in a descriptive analytics? So percentiles we use to understand, like let's say if we are predicting that how much we are analyzing the data to see that how much are the students able to achieve in the just a second. Okay. Yeah. So, for taking the example of percentiles, let's say we are having the data that I will take the example of Swiggy's case, which I have seen in the past. So, in during my time at Swiggy, we had seen various frauds, and one of the frauds was that there were stealings of orders. Okay, so I had to build up some rule or to so that the stealing does not happen in X city. Okay, so for that, I had analyzed the data to see that what kind of people or what kind of delivery executives are doing the most frauds, and for that I found out like the starting ones, or sorry, the new joiners are the ones who make the most frauds because they are new in the system, so they have a higher chance of doing the frauds. This is what mostly happens in all delivery companies, these quick commerce companies. Okay, so they may steal the order and sell it for higher price or whatever. So I had to understand like what kind of now under those newly hired individuals, I had to see that how many percentage of people are able to deliver good orders at least in the system. Now let's say if someone is new in the system 0 to 10 days, now I had to figure out that how many successful orders are 99th percentile or whatever percentile of people are able to deliver. So for that I will use percentiles. Basically I will make percentiles like 100 segments of the data which is available to me, and based upon that I will see that the mean value of what is the mean value of that say a single segment. So 99 segment, like from if I talk about fifth percentile, so it is the from first to fifth values, how much are they able to deliver successfully number of orders. So fifth to 10th and etc etc. So this way we use percentiles like 99th or 98th whatever to see that how much are 99% of the janta or delivery guys or whatever the case we are having are able to perform. Okay, coming up to the next part, graphs we use a lot, there are different types of graph, histograms, pie charts, etc. So we use them day to day for descriptive analytics, like based upon the data which we have analyzed and all, we will next move on to what all uh, how has it happened, and give it a visual sense so that the senior hierarchy is able to make data decisions from it and understand from that. Okay, so this is the basic maths which we used, and in the descriptive analytics part. Now I will come to the uh, diagnostic analytics. Okay, so when diagnostic analytics, the word itself says diagnose. So diagnose, we are diagnosing that if something has happened, then why it has happened. So I had mentioned I will be covering these two major here, which is correlation analysis and linear regression. Okay, so to understand the diagnostic analytics, we will use correlation analysis a lot. We have used correlation analysis a lot. There are other techniques as well as hypothesis testing and all, but the major ones which we the most basic one which we use is correlation analysis to see like what is the relation. Now, as I mentioned in my biscuits example, like the price of biscuits has went from 5 rupee packet to the 6 rupee packet. So why is that happened? So we use correlation analysis under there. Now here I will be explaining a bit of maths for this. Just give me a second. Yeah. So the correlation analysis which we do, it works majorly on the Pearson correlation coefficient. It is a type of technique which is there in the math space which we use, and based upon that we see that how much is our two columns able dependent on each other. Okay, now in this Pearson analysis, we basically what we do, we take the mean of the both the values which are available, which we are measuring for the correlation. Then we take the sum of all the sum of the product of the differences between each value. Now if let's say there are 10 values in it, now we usually take the difference from that value and the mean value and multiply it with the other do the same with the other value. Okay, and then we take the square of that multiple and underroot it, and via this we are able to obtain the value of this Pearson correlation. The formula for this, let me type it in the chat. Just a second. I will be needing YouTube for this, I guess. So, okay. I will be requiring YouTube login for this, so I'm not able to paste it in the chat. But okay, so this is how the correlation analysis work. Let me present my screen. Maybe, yeah, this is the best way to present. So as we can see here, this is the formula for correlation analysis. So this goes like xi minus x bar. So we take the difference of each value from its mean and multiply it for the same for the other values, and then we take an under root and square it, and yeah, this is how the and multiply it of these the sum of these, and this is how it goes. It has three values. Its value ranges from -1 to +1. If the value is +1, then that means that the two values are highly correlated, basically. And if the value of R, the correlation, correlation value is -1, this means the both the values are inversely proportional. This means that if one value increases, the other value decreases, and vice versa. So this is, and if the value is 0, then this means that there is no correlation between both these values, and yeah, this is how it goes. Let me come back to the slideshow. Yeah. So this is how correlation analysis goes. This is the maths behind it, and we had sometimes studied it in our past, in our school times and all. The linear regression works on a similar basis, like we are plotting the values of. We use linear regression in the diagnostic analysis analytics as well. It is a part of ML though, but we use it so as to understand just a sec. Yeah, we use linear and regression so as to understand that how are two values performing based upon it, like if let's say we are having two values, the marks obtained by a student and the number of hours that student has studied, just the basic variables. Okay, now we have a graph about it and we plot it. Okay, now the values which are coming up for each of that, we look into that, and we via that we predict, we decide the value of R, the correlation as well, some way. And via that we sometimes train our models as well, we train our models as well using the linear regression, and using that model we make the predictions as well. Let's say if someone has studied 8 hours, then how much marks are they will they achieve, although this is an hypothetical example, but based upon the data or based upon the formulas which we are having, we do this. In this we are using linear this linear statements, which is y is equals to mx plus c. It is a kind of it is the type of uh, equations which we had studied in our school times. So yeah, in linear regression we use this. In multilinear regression we use polynomial statements like y is equals to c plus m1 x1 c plus sorry and c plus m1 x1 plus m2 x2 plus m3 x3, this way. So this way we use linear regression in the diagnostic analytics, so as to see that how as two values performing, and to diagnose that if something is happening, then why it is happening. Okay, coming to the next part. Now there are some helpful links which may help you to get yourself in the analytics space. I had this much of maths to discuss only. These are some helpful tools now, and like cognitiveclass.ai. This is a free tool from IBM. It is having courses, and you can do it for free, and it will provide you badges. First things first, this is not sponsored from any company and all. These are my research, and this is all purely my research, and I have done it all based upon what all experiences I have. So sharing it with you, the gist of it. So this is firstly cognitiveclass.ai. You can take a screenshot of these resources. Okay. So you can do courses of data analytics and data science and everything from cognitive class. Then next is Cloud Skill Boost from Google. Now we are a part of we are doing this under the TFUG thing, TFUG Ghaziabad. So obviously we need to mention the Google tools as well. So Google Skill Boost, basically these are the courses from Google, and it helps a lot to the uh, it is having various materials like for data analytics it is having, for web it is having, for AI it is having. So if you are new in the, if you are a student and if you wish to explore more a specific industry, you can do free courses from here as well. SQLboard.com. This is a tool which we use, which I used to learn SQL from the basic, from zero. So if you want to learn SQL from the zero, like you don't know anything, you can use SQL Board. HackerRank, obviously we need coding practices and all. The Neuron Daily. This is a free AI newsletter which we are having, which is available. It is from two students from Stanford, I guess. You can go through it. It is a daily newsletter, and it helps a lot to keep you updated with the AI space. For basic maths, you can use 10, 12 NCRT. Like for the rules which I discussed, like for descriptive analytics and diagnostic analytics, the maths of 10th and 12th is enough. We do not need anything else from it. I will count till five now. You all can take the screenshot of this resources, and then after that, I will move forward. Okay, one, two, three, four, five. Okay. Now the ground is open to questions. If you wish to connect with me, you can connect with me on LinkedIn. I'd be happy to help you with anything which is there. And yes, now the ground is open for questions. I'll be taking the questions. You can type it in the chat box. There are a few questions which are already available. Let me answer that. So the first one is how analytics tie into machine learning. Okay, so in my slide, Millie, just a second. Yeah, in the predictive analytics part, we use a lot of ML techniques. Uh, uh, Let me go through your question again. Sorry. How analytics tie into machine learning. Okay, sorry, I took it the other way. Yeah. So in machine learning, analytics plays a major role. Like we cannot build up a model directly. Obviously, we have to do some analysis. We have to understand the data as well, and then after understanding everything, uh, we decide that which specific uh, columns, or sorry, which specific values or columns we need to consider to build up the model. Now for example, as I took the biscuit example, so there were some key columns which came into my mind, like we can use the we are having the rise in the price of the raw material, for example, or the transportation cost has increased. So for building up the model to understand, to decide that how much will this value change, or how much the price will change in the further future for this specific entity. I'm taking the examples of biscuit for this. We need to analyze first and know that which columns are specifically needed for this analysis. We don't need that how many sellers we are having in this, as much as we need to know the price of the change in price of our raw material. Okay, so this is how analytics ties, like it is the first step of ML. Firstly we analyze the data, then firstly we clean and process the data, then we analyze it, then after our analysis we decide what is our goal, and based upon our goal and our analysis we decide which all variables or columns to consider for the ML part. Okay, so this is my answer to your question. Now I'll be coming to Madhur's question. Most of the times we consider mean as the metric. Why mean and not median? Can we use median as the main metric? Okay, so mean is directly the average. Now it is not that we just consider mean only. There are many scenarios that like if for example the standard deviation is negative, or if there is if many a times we are having data and we have to fill up the values. Now for example we are having data of 10,000 records and there are some missing values. So we will be using when we are filling up the values, we do not always use mean. Many a times we use median as well, and many a times we use mode as well. It depends on the data as well, like what kind of data it is, like how is the data segregated, as well as uh, how do you say, firstly how is the data segregated, secondly what is the dispersion of data, like the standard deviations as well, because we do not directly arrive to the conclusion that okay, hamari value missing hai, we are having this value missing in our data, so let's pick up the mean and put it over there. We do not do that always. We measure other metrics as well, and some of it, mostly we check the dispersion of the data as well, because if the data is not if the data is skewed, like if it is highly skewed, then we need to use the values like median, because we cannot use mean in that scenario. So this way we use measures of central tendency and skewness and kurtosis as well, to take the mean, or you can say replace the values. Okay, I hope it answered your question, Madhu. Coming to Millie Shukla's another question. What are the tools that are commonly used in data analytics? Good question, Millie. The tools which I commonly used are, please write it down. Okay, let let me present it from one of my other slideshows. Just a second. Just a second. I'm not having that. So just a second. Sorry, people, for the delay. Just a, yeah. So sorry, I'm not having that slide handy, Millie. So yeah, the tools and technologies, tools which are commonly used in data analytics are, firstly the Python programming language and SQL. These two are the most basic programming languages which we use. R is also being used, but I personally say that one should learn Python because it is more versatile. R is around data analytics or data science only, but Python has a wide usage, and you can use it everywhere, like for building up programs and everything. Okay, so you can use Python there, and apart from this, you also need BI tools like Power BI, Tableau. So you can learn that as well, and Google Looker as well. It is also one of the trending tools which is there. Excel you can use too. Excel is the one which is used a lot these days. Like the senior hierarchy doesn't usually prefer those fancy dashboards and all. They directly say कि भाई Excel में data डाल के देते. So you need to be a master of Excel as well. Many of the companies use hard coded Excel dashboards as well. So Excel, Power BI, Excel, BI tool, coding, which is the Python and SQL, Python and R, Python or R and SQL, and the maths which I mentioned, which is 10 to 12 maths is enough. Uh, Mastering these all tools will train you to get the entry level job of a data analyst, and you will be able to solve the descriptive and diagnostic type of analytics problems easily. And if you learn some bit of machine learning also alongside this, it will be helpful too, like the basic regressions. If you learn that, is enough for this. So yeah, if there is any other questions, guys, please feel free to drop it in the comment box. I'll be happy to answer. Someone have does someone have any other question? Okay, I guess it's no. Then thank you guys. Thank you for joining. Thank you, Sarita. I guess we are done with the questions and everything now. Over to you then.
Yes, Vikram. Thank you so much for such an informative presentation. And yeah, the question and Q&A session is already addressed. So
Your
thank you
voice is
everyone
breaking.
for your
Your voice is
questions.
breaking.
Um,
Yes, you are now
is
audible.
it
Yeah.
good now?
Yes, it's good.
Okay, so I was just thanking you for such informative presentation, and I was just saying like the Q&A session is already addressed. So I'm thank you all the attendees for your questions and your active participations. We hope you found your answers very helpful and you cleared all your queries. So, guys, this video is going to be live on our YouTube channel, that is TFUZ Ghaziabad channel. So you can watch it, share it with your friends and peers, and yeah, you can also connect with Vikramjit. We have already pinged the LinkedIn ID in the chat box, so you can just visit and have a one-on-one question or queries and whatever you wanna ask. And yeah, before we wrap up, I want to just do a huge shout out to our amazing speakers throughout the event and our TFUZ whole TFUZ team and the people associated with us, because this is the end of our ML Math Club. And you guys are phenomenal because this is a huge success for our TFUZ team. And yeah, I also got some exciting news. We are having our offline event, that is that's the name of the event is Meetup Zero Gen AI edition. It is happening on 3rd of the August. So if you guys happen to be around, then you guys can attend our event, and we also get a chance to meet face to face. And you can involve yourself in discussions, and we can connect, and also have like lot more of connections and connect with amazing people. So yeah, we are looking forward to see you there. And yeah, once again, thank you all for joining us today. Have a great evening ahead. Thank you.
Thank you, Zarita. Dropping off now. Thank you.
Yeah,
Bye.
yeah, thank you.